Hello, everyone. Welcome to an introductory tutorial on building Napari plugins. I like to call it from code stub to Napari hub in 30-ish minutes. You'll notice this video isn't 30 minutes long. I don't actually know how long it is as I'm recording this, but it's roughly 30 minutes long. And the even more focused among you will probably notice the time stamps changing for far longer than 30 minutes, but I will say that I have done this in 30 minutes before, so I don't feel too bad about lying to you. Let's get to the point. What are we going to cover today? First thing is, what are we building? So we're going to build a plugin that can help us in competing in the cell tracking challenge. So we're going to build a reader and a widget for running a segmentation on an image, and a writer for the segmentation that we get out. And it's all going to be based around the data that the tracking challenge provides. And I'll show you an example of what exactly we're building before we start building it. I'm going to show you how to use the cookie cutter, the Napari plugin cookie cutter, to create a template plugin. I'm going to show you how to configure secrets for your repository, for a new repository, for automatic deploying to PyPi. I'm going to give you a tour around the package that the cookie cutter creates, so you get familiar with the different files and folders within it. And then we're going to get to build it. We're going to build a reader, a widget, two widgets in fact, and a writer. And here we're going to be focusing not so much on writing the processing code, but more on, if you have some processing code, or if you have some code that loads a file, how do you then connect that to Napari so that you can have a plugin that can load that and you can share that with other users. Once we've built it, we're going to do a little bit of testing and show you how the cookie cutter is configured to run tests, and how that looks on GitHub as well. We're going to show you some pre-commit quality checks that we highly recommend you use to make your code more readable, and to make sure it's configured correctly for best practices for Napari plugins. We're going to show you how to configure your package for the Napari hub and some of the different options that you have in order to do so, including previewing the way your plugin will look on the Napari hub before you release it. We'll do a little bit of just opening a pull request and again, just previewing your plugin for the hub. And then if all goes well, we should be able to merge and deploy the plugin to PyPi and to the Napari hub for everyone to enjoy. So without further ado, let's get into it. Okay, our goal: participate in the tracking challenge, build a plugin that can read the tracking challenge data and the ground truth that is provided with it, and then do a little segmentation on it and compare that against the ground truth, and then save all of that back out. So I've downloaded some of the tracking challenge data, and that's in this folder here. And there's two data sets in there, and we've got ground truth, so GT for ground truth, and then just like the volume itself for each data set. So if we have a look inside here, we can see there's 30 TIFFs, 30 frames. And inside here in the segmentation, you can see we've just got a subset of those frames. So the manually annotated ground truth was only done for a subset of the frames, and then numbered here so that we know what frame we're going to impose it on in the original data set. Now, if we open the 2D plus T data set just with native Napari, we can see that that opens fine, right? So these are our cells, these are what we're tracking, and there's no issues there. But if we just open the ground truth segmentation with native Napari, we can see that all of the annotations are kind of just bunched up at the beginning, because of course Napari has no way of knowing that, hey, you should distribute this across the 30 frames. And additionally, it's an image layer, not a labels layer, again, because Napari can't tell. So we need to use our reader to read this. So this is what we're going to build, is a reader that can take this folder and once it opens it, open the labels in such a way that we've got the frames distributed appropriately. So this is frame 2 and frame 2 down here. We can see that we've got them overlaid. And then once we've loaded them, of course, we actually need to do the segmentation. So that's just going to be a simple thresholding segmentation. We're going to select our image layer. Let's just pick triangle as the thresholding method. And that's going to produce our segmentation for us. So that's our segmentation there. You can compare that with the ground truth. It doesn't look like we did that well, but we also have, just in case we start doing really well, a little widget that can highlight the differences between our segmentation and the ground truth. So the ground truth is selected there, and if we select our image segmentation, then we get a new layer that's going to highlight the differences between those two. That does take a little minute. Okay, so there's our segmentation difference here. So all of the areas that are highlighted are things that were in the ground truth, but our segmentation didn't pick up. But let's say we are happy with the segmentation, then what we're going to want to be able to do is save that segmentation out so we can share it maybe with our friends. And for that, we build a writer. So I'm going to try and save the selected layers. And we'll just put that in demo. And as you can see, we've already got our writer selected here, the workshop demo label zipper. And I'm going to write to zip just because that's going to be easier to share with my friends because it's compressed. And I'm just going to call that tracking challenge zip. And that's going to go ahead and write out. And there it is. And if we open that up, we can see that we've got our segmentation, all 30 frames of it, ready to go to share. So that's the entire workflow that we're going to build out today, and tune in for how we're going to do it. Okay, so we're going to build out our plugin, and I want you to imagine that we have all of the functionality that we need in code somehow, in terms of we know how to load the data into a NumPy array, and given that NumPy array, we know how to run the segmentation on it, but we just don't know how to hook it all up to napari. So that's what I'm going to focus on today. So we're here in the tracking challenge demo environment. This is just an environment that's got napari installed, and it's got cookiecutter installed. And cookiecutter is the package that we're going to use to create a template plugin that we can then just sort of modify with our own functionality rather than just starting entirely from scratch. So we're just going to go ahead and run cookiecutter on the appropriate URL. And you can find all of this in the description. And yes, we're going to re-download it again. And then it's going to ask us some questions. So the first question is the full name there, email, your GitHub username, which if you provide, we'll be able to create URLs for you, like your source code URL and a bug tracker. But you can also choose to have that built later. I'm going to call the tracking challenge demo. As you can see, it's built the URL for me, and that's the one that I want because I've already opened an empty repository behind the scenes. I'm fine with that for the module name. This is going to be load. Now we want something a bit snappier. Let's do tracking challenge solver, which is probably a bit of a stretch, but we'll go with that. And this is a demo plugin to load, segment, and save tracking challenge data. We're going to want to read a plugin. We want a writer. We don't want to sample data. We're not going to cover that today. We do want a widget. We do want to use git tags for versioning because we're going to want to have automated deploys whenever we tag a release. And we do want pre-commit because that's going to provide us with a lot of nice checks for sanitizing code and a couple of Napari plugin specific ones as well. So it's just going to go ahead and create the plugin now. And that just takes a little bit because we decided to install Precommit. And there we are. So we're greeted with a whole lot of instructions here on exactly what we need to do next. I strongly recommend that you follow those instructions. There's more detail in the cookiecutter README as well. So if you have no idea where to start, obviously watch this tutorial, but definitely also go and check out that documentation. And so we can cd now into the new folder that was created that contains our package. And if you have Git installed, you can check your log and you can see that we've got an initial commit already. And because I've already created my repo, I'm going to add the remote. Might actually already be added, let's see. No. So I'm going to add the remote. And I'm just going to copy over the URL because again, there's one I prepared earlier. And then I'm going to push what we've got for now to main. In order to set up automated deploys, we need to make sure that we add a secret to our repository to make sure that it has access to PyPi. So I'm going to show you how to do that now. The process to add a secret to your repository for the API token for PyPi is all covered in the cookiecutter README, which I've already spruiked, but I'm just telling you again, and I'm just going to follow that flow there. So this is the repository that we just pushed to. You can see all of our code there, and we'll take a little tour in a moment. But we're just going to go to the settings tab, and in secrets, then actions, you can see here we've got environment secrets and repository secrets. And we're going to add a new repository secret. But first we have to go to our PyPi account settings. And then down in API tokens, choose to add a new one. I'm just going to call it TC demo. It really doesn't matter what you call this one. And I'm going to scope it to all the projects, but if you've already created a project for your plugin, you should probably scope it just to that. And you have to copy this token now. As it says, it'll only appear once. But once you've copied it, you go over to your repository, make a new secret. And this one you're going to call Twine API key, which you can see I've used before, because that's what the workflow expects, the deployment GitHub workflow. And you're just going to paste your token in there and add the secret. And that's it. You're configured for automatic deploys. Obviously, if you don't want automatic deploys, you can skip that step. Now that's configured, let's take a look at what the cookiecutter produced for us. So we're inside the tracking challenge demo folder. And this contains all of the files that we need for our Python package, which eventually will be a plugin. If we open it up, we can see there's a bunch of configuration files like the license and setup.cfg. I'll go into a bit more detail about those. And then an src folder, inside which is all of the Python code that our plugin needs, as well as napari.yaml, which is the manifest, as we call it, that connects your code with Napari and tells Napari what code to run and when to run it. Let's open that folder in VS Code now, so we can take a more detailed look at the files. The first file I'm going to show you is setup.cfg, and it contains most of the metadata that's needed for your package. And this metadata is also listed usually on PyPi. So you've got the package name, that's going to be the name that's used when you pip install. You've got your own information, the URL to the repository. We've got a framework napari classifier, which is how the Napari hub finds plugins. And then we've got some configuration options. So here is where you list your dependencies in the install requires section. And I'm just going to copy over our dependencies. We're going to depend on Napari. You don't strictly have to, but because we're going to be importing some types, we're going to depend on that. These are some optional testing extras for running tests, but that are not required to be installed for your package to run. And then here we declare where we're going to find all of the code in the src folder, as we mentioned. And crucially, we declare this entry point. So this entry point is how Napari is going to determine that this package is actually a Napari plugin. And all that is saying is that you can find the manifest for the plugin called Tracking Challenge Demo at this path here, which is within src. And so if we go there, so src Tracking Challenge Demo is the folder, we can find napari.yaml and open it there. Just going to save those dependency changes. So this is our manifest. It looks a little complicated, but I promise it's not that tricky. This name just has to be your package name, and this display name is how your plugin is going to be shown in the viewer. So you can try and make it a little bit more descriptive than the package name, which has to be unique across PyPi. So sometimes it's not the most readable thing, and sometimes you want it to be short as well. But the display name is sort of how you can get around that and make sure that you're still meaningful to users when your plugin is viewed in the viewer. And then the bulk of the manifest is this contributions entry. And there's two types, I guess. There's commands, which link, as I mentioned, link an action to Python code that you've already written via the Python name. So this Python name is a path to a function inside one of your files. And if we go to reader here, we can actually find a function called napari get reader that we're linking to here. And each of these commands typically has a dedicated contribution associated with it. So the reader, whose ID is Tracking Challenge Demo get reader, has a reader command associated with it. And we can see here that this reader doesn't accept directories and it only accepts .mpy files. That's just by template, right? So that's what we've been given initially. And each of the other types of contributions, like widgets and writers, also have their own entry in the manifest. We're going to edit this manifest as part of the plugin that we're building, but I wanted to show it to you because if you really didn't want to sort of, overwrite everything or reinvent the wheel, you could just start changing this. For example, if you wanted to make a CSV reader, you could just start changing that to a CSV and then going here in Napari get reader and changing the functionality to match what you want to do. But let's have a look now at how we're going to change the reader to do what we wanted to do, which is load the tracking challenge ground truth data. Now, as I mentioned, the code for the reader is in the reader file, which we can find here. And each reader is made up of two functions, really. The first is what we call the getReader function, and its job is to take the path that's trying to be opened and decide whether that's a path that it can open. So for the default reader that we just get with the template, the one that reads NumPy files, it sort of just checks, well, if the path doesn't end with NPY, which is the NumPy extension, then return none, which means we can't read this file, sorry, try a different reader. Otherwise, if the file does end with NPY, then we return the reader function. And the reader function, whatever you want to call it, takes the same path, but actually does the loading of the data into an array or into a layer. And then it returns that layer as a tuple. So we get a tuple, a list of tuples rather, where each element is one layer or one layer's worth of info. And that info is comprised of a tuple, which is the actual data, which is a NumPy-like array, any keyword arguments that we want to pass in, such as the name of the layer or color map information, and then the layer type, which for this NumPy loader is image. So that's the contract between Napari and Reader plugins. If you can read the file, give me the function that can do that. And this Napari get reader that does the checking of whether or not we can read the file, that's what we connect our manifest command to. So I'm going to copy over the implementation of Napari get reader for our tracking challenge data. And I've made this one pretty specific. I would encourage you to make your get reader function pretty specific as well. So do as much as you can not to claim files that you're not going to be able to read. For example, if you know that you only read a specific kind of TIFF or a TIFF that's named in a specific way, try and make sure that you don't claim the file. And you can do that either by just being really specific in your file name patterns, or by being really specific in this get reader function. So I'm just going to copy over also all of the import statements and other bits and pieces. This implementation relies pretty much entirely on regex. So these are pretty complex, ugly regexes that determine whether the path that we've given follows the folder structure that we saw for tracking challenge files. And as we can see, it does all of those checks, making sure that the path matches the regexes and that there are TIFFs inside. Again, I'm not going to focus too much on the code. And then if that's all good, then it returns the reader function. And the reader function just stacks up all of the TIFFs inside the folder and the majority of and returns them. And then the majority of complexity actually in this file is in this function is just that we want to make sure we're distributing those frames appropriately. So all of this code is just making sure that we find the associated image data and that we distribute it appropriately. So now that we have these, we just have to make sure that our manifest is also in order. So we didn't actually change the name of the function or anything. So we can leave that Python name the same. We might want to update the title to something like open ground truth tracking challenge segmentation data. And then if we go down here to the associated reader contribution, we actually do accept directories. In fact, we only accept directories, and we don't have any specific file name patterns because this is not quite complex enough to allow us to do the regex that we need. We can't specify glob patterns that specifically. So that's all the changes that we need to the YAML and to the reader. And the next step now is to actually install our plugin into our environment, and we're just going to do that with pip install -e dot, making sure that we're at the root of the package. Now that's installed, we should be able to try our reader. And hopefully, if we've configured everything correctly and copied over the code correctly, we'll be able to read our data. Now let's read our just initial, well, first of all, we saw our plugin there, so that's a good step. This is just our initial images, but let's make sure that we can read the ground truth correctly, because that's what we were focusing on with our reader. Make sure we select our reader there. And there we go. And we actually happened to be over a frame with annotations on it. But if we scroll through, we can see that not all of the frames have them, only the correct ones do as a result of our reader, which is great. Next up, we have to do our writer. And sorry, next up we have to do our segmentation and our difference highlighting widget. Cool, so we're back in the code now. And the next step, as I said, is building out the widgets. I'm going to focus today on two main ways to define widgets. The first is via subclassing QWidget and defining all of the functionality inside the class. And the second that I'm going to focus on, so not this one, the second that I'm going to focus on is building a widget from a function using the Magic Factory decorator. There are benefits to both, but I'm going to start with the Magic Factory decorator. And I'm going to copy in our Magic Factory widget, which is going to be the one that allows us to segment by threshold. So that's the definition of the function. I'm also just going to copy in all of the sort of import statements that we need. All right, let's just copy all of that in. I want to show you the threshold enum. This is going to allow us to provide a drop down in the widget that allows you to select the different thresholds, and that's going to connect them to the different functions within scikit-image that are going to actually be doing our thresholding. Yes, and I did forget to copy over some things, because as you can see, it is complaining. So let's have a look at this function. I'm just going to minimize it to start with. So it's decorated with Magic Factory, and we can see that we've type annotated its parameters. So it takes two parameters, one of which is an image layer, and we've type annotated that with napari.layers.image. And the second is a threshold, which is the enum that we've declared up here. And you'll notice that inside the function itself, there's actually no sort of widget type code. There's no, I'll add these items to a drop down or click this button to do something. It's all purely the code that we need to perform the segmentation on the data. So, we get the data from the image layer, we make a binarized image out of that, and then we just label using scikit-image's labeling function, we just label that binarized image. So all of the widget constructions happens with the Magic Factory decorator, and the fact that we've type annotated these arguments allows Napari and Magic Factory to determine what elements they're going to put in our widget. And similarly, the fact that we're returning a Napari layer data tuple tells Napari that whatever we're returning out of this function should be added as a layer to the viewer. So this is the easiest way to define widgets, particularly if you just want to take really simple input from the user, such as an integer or a layer or some layer data, and perform some processing on it and then return something. It provides some customization. You can provide some customization, configuration parameters to the Magic Factory decorator. I won't go into that here. But this is the function that will provide our widget, and we can refer to it in napari.yaml in the manifest. So I'm just going to remove that one because, as I said, we're not dealing with this today. But to refer to the Magic widget, we simply need to replace this Python name that was originally pointing to the example Magic widget with the function that we have written, which is segment by threshold. So we just update that reference there. And of course, we should update this title as well. This would be make segmentation threshold widget. And the display name here maybe should just be segment by threshold, because that's what we're going to see in the menus. And we could update the ID as well, but that's not shown anywhere, so I'm not actually going to bother. So that's how we refer to a Magic Factory constructed widget. Now, the other way to construct a widget is, as I mentioned, by subclassing QWidget. So I'm going to copy in the relevant QWidget now. And what this widget is going to do is the difference highlighting. So if you cast your mind back to the demo that we did, this is going to highlight all of the things that we didn't segment, but were in the ground truth. Obviously, the first thing we're going to notice about this widget is that it contains a lot more code. This is left over from the previous widget. It contains a lot more code than our segmentation widget. And the reason for that is because if we're subclassing QWidget directly, we have to make sure that we're laying out all of our buttons and laying out all of our drop downs and everything ourselves. And that just requires a little bit more overhead. What we do get, though, by subclassing QWidget is we get complete control over behavior, over the layout of our widgets. We can, swap out elements of the widget as we need, and it just provides more flexibility. Of course, at the trade-off of complexity. Another thing to sort of point out here is that Napari widgets, or rather QWidgets that will be used in Napari as part of a plugin, can take the Napari viewer object. And if you save that in an attribute, that allows you to access all of the information that you otherwise would have about the viewer, including its layers, its camera positioning, world coordinate information, anything that you might want to know about the viewer, you can do that through this attribute. And so that allows you to connect your widget up really nicely to other parts of the viewer. So all we're doing here is laying out combo boxes, adding options to combo boxes, and the true, functionality that as I mentioned, you might already have written before you started with your plugin, is this compute difference function, which we can see at the end directly adds the labels layer. So rather than returning a tuple for the layer, we can add it directly to the viewer using the attribute that we previously saved. And this runs whenever we click on the highlight button. So whenever we click on the main button of the widget, we run compute differences, and that's the sort of event-driven flow that you would need to have. And linking to this widget in the manifest is pretty much just as easy as linking to a Magic Factory widget, except rather than ending your Python name with a function, you end it with the actual name of your widget, which I'm just going to copy. There we go. And because we've actually changed these functions, the final thing we need to do is just make sure that we're exposing them correctly in the init. So we didn't need to update the reader because we didn't change the name of that function, but we have changed the names of these. So we just need to make sure that we update that correctly. And that is all of the changes that we should need to make in order to have our widgets pop up in our plugin. And let me just make sure that I have removed references to the one we're not using anymore. It looks like I have. So let's see if that works. So there is our widget. And there it is loaded in the viewer. And now we just need to open our data. So I'm just going to open the original image because that's what we're going to be using to segment. And then let's select any of these thresholds. I'm just going to select triangle. The image layer has already been selected for us. And once that runs, we will have our very quick and dirty segmentation, which is actually not, well, I wouldn't say it's great, but it's something. And then the other widget that we built, and this is the one that we built by changing by subclassing QWidget, is the example QWidget, which I thought we had named segmentation difference, but we didn't, right? So because we forgot to change this display name, this is still named example QWidget. That's something that we should probably fix, and I should probably fix as well. But it allows us to select a ground truth layer, which we haven't loaded yet. So let's load that now using our reader. Let's move that image segmentation on top. So we select the ground truth layer, we select the segmentation layer, and then we highlight differences. And this one takes a wee moment to run. But once it does, we'll be able to see highlighted in orange all of the pixels that our triangle threshold-based segmentation didn't quite get right. And there we go. And so you'll see with that widget, I've also taken the time to make these other layers invisible so we can see the highlight. And that's one of the things that you can do as a result of having the viewer parameter available. Now that we've got our segmentation, assuming we're happy with it, which personally I am, it's time to save it out. So we need to start building our writer. Now with our writer, all we're going to want to do is take this segmentation that we have produced and write that out, as I said, frame by frame to a zip file so we can share it with our friend for bragging purposes. So these are all of the writer commands that this plugin already provides, but we're just going to need one writer. And the one that we're going to take is the one that writes a single image. So I'm just going to remove this command here for writing multiple layers. But if you want to find out more about that, link is in the description to all the references. And we're going to focus on the write single image. Now, for us, it's not going to take an image layer. It's actually going to take a labels layer. And the file name extensions that it's going to write is .zip, right? Because we're going to zip up the labels layer. And in fact, it doesn't just take one labels layer. It could take multiple labels layers. So we can put the star there to delineate that we take one or more labels layers, but we don't take any of the other layers. So we can't write points, we can't write tracks, etc. So that's going to be our writer. And we just need to make sure that we either overwrite this function in particular, write single image, or we come back and change it once we've written our own writer. So again, we're not using write multiple. The contract between Napari and a writer plugin is that we will give you the path that the user chose to save to, the data from the layer that they chose to save, and the metadata dictionary as well, which is going to include the layer name, color map info, any of the metadata that was saved about the layer. And so if you want that to be part of the serialization of the layer, you can do that. And all that this function is going to do is take each of the frames from the segmentation, as I said, write it out to an individual TIFF, and then zip that whole thing up for easy distribution. And at the end, you just have to make sure that you return all of the paths that you saved. So I'm just going to copy that implementation over. And then, as usual, I'm going to copy over all of the imports. Great. And again, we didn't overwrite this, so we shouldn't need to change anything either in the init here oh, actually we do need to, because we removed write multiple. So we can remove that. And I think we've already removed it from the YAML, which it looks like we have. And here again, you can be more specific rather than saving image data. We actually want to write labels data. And of course, write single image probably isn't the best function name for this anymore since it's writing labels, but we'll allow it for now. Okay, and so let's see whether we can now write out our image segmentations. Okay, so I've skipped forward a little bit to where we've already done the segmentation using the triangle method again, just because we've seen that a fair few times. And now we're going to try and write it out with our writer. So we've got the image layer. Sorry, we've got the image segmentation, the labels layer selected, and now we're going to file, save. This is a fine folder to put it in, and I'm just going to call it labels solved.zip. And we should see that write out frame by frame here. And you can see that zip file is created. The other data is removed. And if we unzip this, we'll see it has been saved in a very similar format to the original tracking challenge ground truth data. But we've got all of our frames there that we segmented saved out. So that's all of the functionality of our plugin complete. And now it's time to look at testing and other quality measures for plugins. Once our plugin is working and we start thinking about wanting to share that plugin on PyPi and maybe on the Napari hub, it's really important that we make sure we've written some tests for our plugin. Test coverage, getting some reasonable test coverage is really important because it helps you ensure that your plugin's working the way you intend. And also later on, if you make changes, it's ensuring that those changes aren't having unintended effects. I'm not going to go deeply into testing today. There is another workshop that we've done on plugin testing, and I'll link out to that. But what I did want to show you is that the cookie cutter actually provides template tests for your readers and for your widgets. It provides a very little bit for your writer, not a lot, but you do have some way to get started for the reader and for the widgets if you want to be testing your functionality. I've actually already written tests for all of the functionality that we have written today. And in fact, I think I actually got it all the way up to 100% coverage, but you will be able to fact check me on this after this video is over. So I'm going to copy all of the tests that I have written, and I'm just going to make sure that I'm importing from the correct module, which in our case is tracking challenge demo. So these are all the tests for readers, and I'm going to copy over everything for widgets and for the writer as well. And again, just make sure that we're fixing the imports, and that should be good to go there. And then we will do the same for the writer. And here we are importing from tracking challenge demo as well. So these are all of the tests written. And as I mentioned at the beginning, your test dependencies are already declared in setup.cfg under extras require. You might require more dependencies for testing, and you're welcome to add some, but the basics of what is commonly used for Python testing are already included. And in order to run my tests, which hopefully will work, I'm going to first install all of the testing dependencies. That should have collected all of the test dependencies. And now we're going to run PyTest, and hopefully that will all pass. That's just a very simple import error. Well, hopefully a very simple import error. So I believe, yeah, we did not do. So this is the enum that we're looking for inside the doc widget, but I believe we haven't exposed it via init is the problem. So let me just make sure that this is also imported here. How did I spot that so quickly? Practice, and to be honest, I'm still not sure that's the whole thing. But let's run those tests again. It's looking good. We might still have a failure or two, but hopefully not. We did get some failures. Okay, it looks like we forgot to actually pass through the metadata, which we don't actually have metadata to pass, but of course we need to make sure we're satisfying that argument. So let me just go through and pass those in. This was in the writer. So for metadata, we want none. We just want to pass in an empty dictionary there and an empty dictionary there. Of course, if we were actually doing anything with the metadata, we'd want to make sure we're not just passing in an empty dictionary, but our reader happens not to be, our writer rather, happens not to be. Okay, now that's fixed. Let's try running that again. And hopefully we've caught all of the little buggies. And there we go, 13 tests passing, and at least that gives us some confidence that our plugin is behaving as expected. Next up, we're going to look at some other quality checks like pre-commits, and we're going to open our first pull request into our own plugin. So we want to try and get ready for release. That means we want to, commit all of our changes and push them up to our branch, make a pull request, and maybe get to releasing. And one of the tools that I mentioned at the beginning of the tutorial is the pre-commit check. So pre-commit is a tool that can run every time you try to make a git commit. And it's configured here in pre-commit config YAML as a result of the cookie cutter choice that we made at the beginning. Now, there's a lot of really nice just formatting tools. Checking for doc strings, making sure that lines aren't too long, running general code formatting, and most importantly, as far as I'm concerned, is the Napari plugin checks that Tally has written. So these checks are going to statically inspect your code. They're not going to run anything, but they're going to statically inspect your code and make sure that you've followed the best practices for Napari plugins. So to run pre-commit, the first thing you need to do is run pre-commit install, and that's going to make sure that the pre-commit hook is installed for this repository. Then we're going to check all of our changes. Again, we're on branch main at the moment. We don't want to be committing to main, so we're just going to check out a new branch. And now when we run git commit, add all changes, we should see the pre-commit checks be running. So that's initializing the environment for pre-commit. This only happens the first time and it takes a little bit, but once that's done, we should see the output from all of the pre-commit checks that are running on our code. And I highly recommend using pre-commit for your plugins. If you use the cookie cutter, you get it for free, so there's no reason not to. So as we can see, we've got a bunch of failures. Most of these are just with this line is too long, or you've imported something but you've never used it. But what I really want us to focus on is this right here. So this is a fail from Napari plugin checks, and it says forbidden import detected PyQt5 in this file. Use Qt compatibility library like QtPy. And so what that's alerting to is that here in the doc widget where we've imported, where is it? Here, we've used PyQt5 instead of QtPy. And the reason that it's against best practices to use PyQt5 is because Napari supports both PyQt5 and PySide as Qt backends, as GUI backends. And so it's important for plugins to respect that. And for you to respect that while still, of course, being able to write your code, you can use QtPy as your import and wherever you declare dependencies. And that's going to ensure that both PySide and PyQt5 are basically okay to use. And just to get that commit through, I'm going to disable these checks for now, although, as I said, I don't recommend that you do. And now that we've fixed Napari plugin checks, we should see that there are no issues there. And if we git log, there's our commit adding all changes. So that's great. We're almost ready to open our pull request, but first I just want to show you two things. One is the test and deploy workflow that is provided for you, and this is going to run a GitHub action every time the triggers are met. And so all this test and deploy framework is saying is first, on any branches, on any pushes rather to main or any pushes with the release tag, so like a v0.0.1 tag, for example. And on pull requests to these branches, and when you trigger it manually, we want to run these following steps down here. Now, deploy is only run when you push a tag to main, and that's covered by this if statement here. But testing is run on all pull requests and everything. And here we declare a matrix. It's testing on a number of different platforms and with a number of different Python versions. So it provides a lot more testing capacity than you might just have in your local environment. And the only change I'm going to make here is I'm actually going to remove Windows because I happen to know that I did not write my code carefully enough for the file paths that I've hard-coded to be Windows compatible. So I'm going to remove Windows from here, from this workflow. And you might notice that tests are being run with Tox. Tox is a tool that allows you to configure, again, different testing environments. And from here, I'm also going to remove Windows. Now, again, you don't have to know too much about Tox in order to get your workflow running. Most of this stuff runs out of the box. So if I go back and show you my main branch, you know, this was the initial commit that we made way back when, and you can see that actions actually did run when I made that push, and they were all successful. So I didn't have to do any configuration at all. The reason I'm reconfiguring it now is because I know that I haven't been thorough enough for this code to work on Windows. So I've just removed all of the references to Windows. And now I should just be able to commit those changes. And we're almost ready to open a pull request. Now, once we release our plugin to PyPi, because we have used the framework Napari classifier in our setup.cfg, the Napari Hub is going to pick up our plugin and display it as part of the plugins available here on the website. And when you click through on any plugin, you can see all of the detail and all of the description that the plugin developer has provided. So let's take a look now at some of the configuration options that you have for customizing how your plugin looks on the Napari Hub. Much of that configuration lives in a .napari or .napari hub folder. And one of these is the description.md file. Now, if you don't provide a description.md, your README will be used to provide information to users about your plugin. But we do recommend you use description.md separately to your README, because it's important to have a user-focused description rather than a developer-focused description. So it's important to remember that some of the users of Napari don't have a lot of coding experience. And having a description.md file that targets your explanation towards that level of code knowledge can be really useful. As well as the description.md, this folder can also contain a config.yaml file, which I'm going to add now. And this file can hold all sorts of important associated metadata for your plugin, such as categories, authorship details, and visibility. So in my case, I don't want this plugin to be visible on the Napari Hub in searches, just because I don't want to sort of populate the hub with, a lot of demo plugins. And so what I'm going to do is I'm going to add the visibility hidden field. And that's going to allow me to go to my plugin's URL if I know that it exists, but it's not going to clutter up the search for me just sort of testing and doing demo things. Definitely check out what else you can put in this file, though, again, links in the description, because there's a lot of useful features that it can provide. And in order to support viewing what your plugin details page is going to look like before you release, so that you're not surprised, the Napari Hub also supports a preview workflow. So this is going to be a separate GitHub workflow in the .github workflows file. And this is actually just a like standard template workflow. So you won't have to write this yourself or even edit it once you've added it. And again, links to it will be in the description, but for now, I'm just going to copy in the information that we need in here. And so all this is going to do is on every pull request, it's going to build a preview page for your plugin. And in order to make sure that you see the comments from the Napari Hub bot about your preview page, you also need to make sure that you configure the Napari Hub app. So this is the Napari Hub app. I've already configured it for my own repositories, but when you visit this website, it'll tell you to install. Once you click install, it'll ask you where you want to, what organization you want to give it access to and what repositories you want to give it access to. Again, I've already done that, but that is how you would go about it if you hadn't already. And I think that's actually the last of the configuration that we need to go through before we open our pull request. So let's make that final commit. And let's push that. Now, usually, of course, I would provide a more detailed description, but for now, I'm just going to create the pull request and we'll come back and have a look at our tests and also at our preview page once it's ready. Okay, so here's our pull request, open and live. As we can see, all of the checks are passing, all of our tests are passing, and our preview page workflow ran as well. And we can see here the Napari Hub bot, because we added the Napari Hub app, commented and gave us a link to our preview page. And if we open that, we see exactly what our preview page is going to look like once we release our package. So up here, we've got a checklist of all of the different things that we should be providing to make sure our users have the information required to use our plugin. And then you can see our README, all of the requirements that we have listed, and all of the other information that we've provided, all visible here for us to be able to preview it before it goes live on the Napari Hub. Of course, ideally, we would add a little bit more information to our README than this, but for now, this will do. So assuming you're happy with your preview page, assuming you're happy with all of your tests passing and your coverage, then you're probably ready to merge your pull request. So we're going to go ahead and do that and confirm that merge. And now it's time for release. So we can go back to our Git repository, our local one. We can switch back to our main branch and pull it down. We're happy that these are the last changes. That last merged pull request is the final change that we're going to want before our release. So we're going to go ahead and tag with the 0.0.1, although of course you can tag with whatever number you want, but this is very early stage for our plugin, so we're going to go with a pretty low number. And now that we've tagged that last commit, if you do git log, you can see that that tag is listed there. And we just need to make sure that we push that up to main. And once that's up there, that's going to kick off our deploy workflow. So as you can see, that workflow is running now. We've got the tag up there as well. We'll come back once that's all finished running, and hopefully we should be able to see our plugin live. But again, we're not doing any extra steps. This test and deploy workflow is going to do all of the work for us. So let's go have a look here. Okay, so we're running on the merge. And then once that's run, we will be able to see our deploy workflow as well. So we're a little further along now in the test and deploy process. You can see that our Ubuntu tests are passing, and so is macOS for Pi 3.8. We're just waiting on 3.9 and 3.10. And you can see that this deploy step is just waiting to run. And in fact, if we have a look at the workflow for test and deploy, you'll see that this actually needs test. So basically what that means is if any of those tests fail, we wouldn't deploy, which makes sense because if any of your tests do fail when you've merged to master, you probably don't want to release that. So this step isn't going to run until the remaining 2 macOS tests are completed. And I'll just refresh to see whether or not they're done yet. But it looks like we're still waiting. So we see here the 6 testing jobs have completed, and because they completed successfully, deploy has now kicked off. And if we've configured our secrets correctly and everything, then we should see that deploy step succeed, at which point our plugin will be live on the PyPi and the Napari Hub. Although we'll probably have to give it sort of 5 minutes or so before they're actually available. But let's check back in once that deploy step is successful. Okay, so that workflow actually succeeded about 5 minutes ago, and we can see that the deploy was successful. And if we check here on PyPi, we can see tracking challenge demo. Version 0.0.1 is live and ready to go. And if we go to the Napari Hub and search it, we shouldn't be able to find it because we have, and indeed we can't, because we've hidden the plugin's visibility via the config.yaml file. And that's exactly what we wanted. But if we know the URL and we go to the URL directly, you can see that the plugin is available here with all of the metadata and the description exactly as we saw it on the preview page when we first opened up pull request. So we're done. We went from absolutely nothing, well, not nothing, but just some associated code that we knew did the processing that we needed, all the way to creating an napari plugin, modifying it to suit our behavior, adding tests, making quality checks, and then releasing it to the Napari hub. And that's all there is to it. As I mentioned before, there's a bunch of references in the description going into more detail about each of the steps that we've taken here. There's an in-depth plugin testing workshop if you're more interested in how you can get good coverage for your plugins. But for now, happy building.